Cool. So welcome everybody. Thanks for joining. My camera is being a little weird, so I can't actually see, but I don't know if you can see. My name is Billy Rennekamp. I'm from the Interchain Foundation and Interchain GmbH. And I do a few different things in the space, mostly coordinating around funding to help out the ICF. I'm on the board of management there, and some DevRel work with Interchain GmbH as well. I've been working with Cosmos and Ethereum for a few years. The last couple of years, more Cosmos than Ethereum, but always excited to talk about Solidity development as well. My background was working from actually studying film and art, but moving into a lot of front-end development at some point. And so I was sort of excited to merge some of that work with some of the Cosmos SDK work that I was doing and helping out with DevRel. So at some point I built this little front end that interacts with the name service tutorial. So the point of this workshop is to sort of dig into that code base, dig into that website, talk a bit about what is the next step after you've sort of made that first tutorial with the name service. You've deployed your first blockchain, it's running locally. Maybe you've added some cool features. Like, what's your next step? You want to maybe share that running blockchain with some friends. You want more than one local user to be able to interact with it. What's that first minimum viable launch, let's say, look like? And that often includes as well something like an interface. Your first app will probably be a web app. It's usually the lightest lift, the easiest thing to sort of put in place to allow people to access it. Obviously, it's a lot easier than going through the hellish process of submitting an application to the Apple App Store. I don't know if anybody had the unpleasure of doing that, but so that's really what the point of this app is to sort of demonstrate what that could look like, show you what that process might look like, highlight some of the more thorny edges, and also highlight some of the cool things that become possible. Let's see, I have a little bit of a outline that I wanted to use, but this talk in general was meant to be sort of hands-on. We're going to be opening up the browser. We're going to be opening up a few different code bases. We're going to be in the command line a bit. I'm also going to be opening up some stuff. We're going to be using Netlify for deploying the front-end app. I'm using DigitalOcean for serving the actual blockchain. We're going to be using GitHub for hosting the code and part of the deploy process. I'm also using Cloudflare for a little bit of help around the domain management stuff, but we have some options around there that I'll be happy to discuss as well. We've set this up so that you guys are pretty tightly locked down. Thank you, Philip. I will stop the music. We've locked you guys down pretty tightly. I apologize, but we've had some Zoom bombs, so we start out from this level of security. Feel free to send messages to me privately. I will be able to either say them out loud if it's a question for everybody or answer them directly. Feel free to, stop me if I'm going fast. I know a lot of people here are probably not English as a primary language, and I speak English very quickly. So please tell me to slow down when I'm going too fast. I mean, the point of this is to get everybody sort of in sync with what's going on. If you'd like to follow along with the code, you're welcome to. What you'll be able to do basically is deploy your own front end, which mirrors the one that I'm working with, and you can make your own changes there, sort of deploy it and run it locally and sort of see. I mentioned earlier, I'm going to be using Netlify to actually deploy to a live instance. So you can also go to that domain and start interacting with running blockchain there. I guess be good to sort of maybe get a quick show of hands. Is anybody here not familiar at all with the name service tutorial that's on our tutorials.cosmos.network, which is an explanation to sort of build a kind of full feature Cosmos SDK application? If you want to message me right now, I can get an understanding and I can give a little bit more background on that. And if everybody's kind of familiar, at least with that code base a bit, then we can go a little more lightly over that. Just give you guys a second. Cool. So Michael is not very familiar. Adriana, we got a couple here. Sorry to. Okay, great. So Adriana just posted a link to that. Let me begin by sharing my screen and we'll just jump in there, quickly go over it, and that'll bring us to sort of square one where we'd start talking about something like a front end. So I'm going to try to share just half of my screen so that the screen isn't too large when any one person's looking at it. I'm on this like stupid wide screen, so let's see what happens. There we go. That looks pretty good. And if I pull Zoom back up, somebody send me a chat so I can see where the chats are going now. Don't seem to see them anymore. Nobody's sending me a chat, or is somebody sending? There we go, there's a chat. Now I can see my chat window. Great, thank you. Okay, so let's pull up this tutorial really quick. Pull it back into the screen. So this is just a walkthrough of using the Cosmos SDK to build a name service app. And the primary point of this tutorial is to, what's going on? This is the experimental screen share. It's not letting me click below it. That's a little weird. Okay, we're gonna try that for now. It gives you sort of an idea of the app structure. So if you were to use scaffolding tool to generate sort of a boilerplate app, this is a bit like is available in like Ruby on Rails types apps. It will give you the sort of default. Generally, all of your logic goes inside of this X folder, and this is like a new module, is what we call it. And the module consists of a few different pieces, mostly to do with the handler and the keeper. Let me jump ahead. This sharing screen is not working very well. Okay, I'm gonna stop the share and try something else. All right, hopefully you guys can still see that screen okay. I know it's probably a little bigger than you'd like. Let me see if I do that, if it makes it any better. So that's the basic app structure. Application goals. This just talks about a Cosmos app, usually has a bunch of different modules. So there's the auth, the bank, the staking, distribution. These are sort of like your basic modules to run a blockchain. But we wanted to make a new module that's a name service. And a name service, like DNS, is essentially a record book where you've got something like a domain name, and it's pointing to some record. That record can be a JSON object that contains A records and C names, the way DNS does. It can also be like the way ENS, the Ethereum name service, works, where it's a domain name and it points to an address so that you can resolve a human readable name to an account address. So it's agnostic to exactly its use case, but the general concept applies here. It's a good example of like a decentralized app as well, because it's a bit of something that is kind of like a public utility. And I think that when you ask yourself the fateful question, should this be a blockchain? One of the reasons you can justify it is if it's sort of a common good for many different stakeholders that is, you know, in a traditional sense, the responsibility of running a common good is often the responsibility of something like a government. But in a situation where you don't necessarily have a government, like decentralized community, maybe participants who are across political boundaries or something like that, you can sort of think of a piece of software acting in place of that disinterested third party that a government works as, or one that's meant to be for the benefit of all. And a blockchain really shows up well in that capacity. So a name service, which is this sort of global namespace where people can reserve domains or whatever, you know, this is a common good protocol that has a lot of different stakeholders. So it's pretty justifiable, I think, for being a blockchain app. Anyways, the blockchain as built with Cosmos SDK sort of composes of a few different pieces. There's state. This is represented with a KV store, key value store. This is kind of like a JSON object, if you're familiar with that, except for it's persisted to state. It has sub keys that we call sort of a multi-store, meaning that there's one key that holds one blob, and inside of that blob you could have another key which holds even a smaller blob, and that sort of granularity is associated to different modules or specific tasks within those modules. Messages are where you really should pay attention though. Messages are essentially commands that make changes to the application. So things that actually make state updates. What are things that users can do? If you're sort of designing an application, often you'll think about user stories. Messages are really helpful when describing user stories. What are the things a user can actually do on this blockchain? In our situation, we actually have two, message set name and message by name. So that's if you want to get a name that doesn't exist, you'd buy it. And once you own it, you can set it. There's obviously other messages that are associated with blockchains like transfer tokens or make a governance proposal or become a validator. And those are the ones that are sort of included by default that I mentioned earlier. But we're really focusing on this one new module, which is the name service. I'm going to try to go a little fast here because a lot of this is really about building the app itself, and I'd like to focus on interacting with the app. But if we go through here, here's just some features of the app itself. If this stuff is especially interesting, don't forget to go back and take this tutorial. I think it's really helpful. Types, blah, blah, blah. Who is? So this is a data structure that will return when we ask of the blockchain, what does a record look like? And every name is going to have, a value. So that's where you put something like whatever, BillyRennekamp.com. The owner is the account address that actually owns that value. And the price is what they paid for it. We have a really simple marketplace set up for this so that anybody who wants to buy this is able to, as long as they pay more than the last person paid. So it's a little bit like radical markets, but it's actually just a very simple method that we built in so that you don't need to build a whole interface for bids and asks and stuff like that, and that's not really the focus of this tutorial. So it's just a very simple version. That who is structure shows up in a couple places we'll get to later. Keys, this is more about organizing your app. Errors, this is about giving errors when things go wrong or when somebody asks your app something in a weird way that it doesn't like. Keepers, this is where the actual values are stored, and it has some pretty simple functions attached to it that we don't really need to worry about. That's all under the hood. Keeper struct, this is more under the hood stuff. Getters and setters, this is like how do you update the storage. You're going to keep, you're going to set, and you're going to get, but again, we're going to skip this. It's under the hood stuff. Messages and handlers is the next section. This is a little bit interesting and relevant to us. So generally there's a flow that comes through in these apps. And you have these messages that I mentioned earlier. These are the sort of user stories. You submit these messages inside of transactions to the blockchain. They get accepted into a block by the validators. That's the participants who are actually operating nodes and for one reason or another have been qualified to actually, finalize blocks, to be block producers. In Ethereum world or Bitcoin world, in order to be eligible to do that, you have to solve a math problem basically in a short period of time. In Tendermint world or proof of stake world, you basically just need to have some of this stake. Basically gives you permission to be one of these validators. You have to have enough of that stake to be in the validator set. And then from there, basically just takes turns. It's like a round robin thing. Not really important. We're not going to focus on the validator set so much or the Tendermint. The point of the SDK really is to take away the complications of networking and consensus and let developers really focus on the app. So again, that's why I'm going to skip over it. But you can imagine, somebody wants to do something and that something can be represented by a message. That message gets included in a transaction. They sign the transaction and they send it off to the validators who include it in a block. Once it's been included in the block, it will go to the application, and inside the application, it will get processed first by the handler. The handler is essentially a router where it says, cool, I just got a message. The message is set name. The message is by name. It's some of these message types, these user stories. And depending on what the message is, it handles it. It hands it off to a function that's usually called the by name handler or the set name handler. Maybe we can look at one right here. This is the set name. This is actually making the set name. And then here's the handler of the set name. So here's this switch statement, which is basically a router. It says, oh, if it's the message set name, then run the handle message set name. We can look at the message here. And this is where you can add the logic to your application, where you're really saying, well, I don't want you to be able to set the name unless you're the owner. So I'm going to get the owner of this specific type of name. And if it's not the same as you, then you're in trouble, buddy, and you're the incorrect owner and fail. Otherwise, I'm going to let you set the name. And this is where you set the value that's associated with that name. In DNS world, this would be, all of the A records, C names, and stuff like that. So that's the general flow of these apps. You have a message, it gets handed to a handler, and then inside that, you run some logic, and eventually you persist state in the keeper. That's the key value store, the keeper. So we have a few here. We have set name, we have by name I mentioned earlier. We actually have delete name as well. I think that was a more recent addition here. And then we have queryers. Queryers are basically the same as messages and handlers, except for that they don't update state. So again, you can sort of use this user story idea for designing messages, but messages will actually update the app. Whereas a queryer, maybe the user just wants to know something about the state of your app. So they will make a query, and a query is handled in a certain similar way to this messages handler, except for it doesn't have to go through the whole process of being included in a block. It just goes straight to the app, and it uses a actually kind of a URL style string where essentially it's namespaced by the name of the module and then the name of the query. So there's a query for resolve, there's a query for whois, there's a query for all names. So I mentioned earlier that whois struct, where it's telling you who's the owner, what's the current price. That's what would get returned when you want to query a specific name's whois record. The queryers also interact with the keepers because obviously that's where the value is stored. So if you look at this, this is like a similar sort of router with a switch statement. When you get a query that is the whois, it'll query this actual function. And we can take a look in here where the keeper is used to actually pull out that information. We're going to marshal it in JSON so that when it's returned, it can be easy to read. And then we just return it, unless there's some sort of an error in that marshaling process because we stored it incorrectly or we got back something we weren't expecting. But essentially, it's the sort of same thing. So that's queryers, that's handlers and messages. Alias, this is all under the hood stuff, just organizing your project. Codec, this is the same. The way that the SDK is built is they expect, but don't require you to create, to augment a CLI command client for each of your apps. So all of the modules come with them certain commands that get combined into a single CLI binary. And those make it easy to interact with your blockchain from the command line. So now that we've made this new module that has these special abilities, we want the user to be able to easily construct these messages that will be submitted or construct these queries so they can read some of that state. So this is the section where we sort of outline how do you generate each message type? How do you generate each query? And this will result in actually making those messages for you, but it'll also submit them if you'd like. In a similar instance, typically modules will create a REST interface as well. So this is another client that you can operate from the command line, and it creates a REST server. So if you have something like a web app, you can query this REST endpoint and get back information about the blockchain as well. It used to be that the REST server also let you sign transactions. You would basically send a private key over SSL or HTTPS with your request, and it would sign it. But this is sort of an unsafe practice, and so it's been disabled. So the REST server at this point is mostly in charge of crafting messages. It'll generate the message with all the appropriate fields that you want and return that, but it's going to be an unsigned message. So once you've got it back, you would either want to use some signing library to do that manually. You can do it with a CLI. We're actually going to do it later on inside of a Lambda function. So we'll touch on that in a bit. We're going to use the Tendermint SIG library. There's another new library called Cosmos.js, which will be replacing SIG in the future, but the syntax will be really similar, so you'll be able to reuse that. This is where you basically register the routes of the REST interface. So these really closely mimic what you'd expect. You know, they're either gets or puts that allow you to query via this URL. It really mimics traditional web app interfaces. So we'll look a little closer at those later. Here's the one for the queries getting handled. This is a little bit redundant from the other section, but if you want to take a deeper look, again, this is the place to do it. This is where everything gets tied together at the top level. This is the app, and this is where you basically import all of the different modules you want to use. Or sorry, this is the module section inside of the name service. This is where you combine all the features of this specific module that gets imported into the top level app later. Genesis, this has to do with starting new apps from old apps. So you export state, so you can start with like a bunch of names that are pre-registered or something like that, or you can start a blockchain with a bunch of users that already have coins. This is the complete app. This is what I was mentioning a second ago on accident, that where you sort of describe what your application does. So you pull in all the like basic stuff. It has authentication. It has bank, which means it knows how to handle coins. It does slashing and staking, which means that it uses Tendermint and a proof of stake way. And here is where you say it also has this new app, this new module called name service that we define here locally. Tie all that together, make a new name service app, put that inside of your build commands, blah, blah, blah. This is the build commands. We call it NSD for name service daemon. This is a binary that's going to get created in order to actually run the application. And then here's the NSCLI. So this is our client library. This is where all the command line interface options get combined into a new binary, as well as a command for running the REST interface. So those are the two binaries that come out, and those are the ones we're going to be using. We have a make file that basically describes that process. Here's some extra instructions if you want the ledger to be the signing solution, but we're not going to be doing that today. Go mod is where it sort of describes all of your dependencies. We don't need to worry about that right now. Running a second node on another machine, that's sort of advanced level. Running the REST routes. So this is showing you sort of what is the command to run that REST server I mentioned earlier. It looks a little bit like this. I'll show you again with our specific use. But that'll give you the ability to run commands like this. You know, you can, curl just sort of demonstrates it. You can do this inside of a browser as well, where you go to, if it's running on your local host there, the default port is 1317. And then you put in the URL like a query you might expect. I want to know about the authentication module, which tells you about actual users. And I want to know about accounts. And I want to know specifically about the account owned by a user named Jack. So that'll return a JSON object that says, yeah, I know about Jack. His address is this. These are the coins that he has. These are all of them in a row. This is his public key. It's the value of it. He has account number 0, sequence 1. That's like the nonce of the account. So these are really great and helpful pieces of information. Here's the ones for our specific app. So this is a post request that is asking for, oh, this is actually submitting a transaction. Wow. We're not going to do it this method though, so we can skip over request schemes, blah, 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 blah. We don't need to get too much into this. Great. Okay, so that was a very, very fast overview of the name service application. Really quickly, are there any questions about that anybody wants to raise before I go on and show you a bit of the front end? Going once, going twice. No questions. I thoroughly explained everything perfectly. Great to hear. Okay, so I have compiled and deployed an instance of this application, this name service application, which is available at Cosmos /SDK tutorials/name service, this one. You can click here and go in. This is the instructions for it that we just went over, but you can also look at the actual code here. So that's, you know, this module that we just built, the handler that I was talking about, where you can see the switch statement, here are the 3 different message types, et cetera, et cetera. So anyways, I built that app. just by cloning it and compiling it with a make file. I ran make install, and then I put it on a new DigitalOcean server. So here's my DigitalOcean server. It is a very small one. It's the $5 a month one from DigitalOcean. I did augment it a little bit. And one of the things that I did, one of the things one can do is you can turn on UFW. So this is a way to open and close ports if you want to be a little more secure with your server. You can also not worry about it at all because these are all sort of demos, and this is meant to be very early sort of development cycle for testing out capabilities of your application. The other thing that I did was increase the swap. So the swap is the sort of virtual RAM that's available to your machine. And if you're going to use this DigitalOcean $5 a month one because you're cheap and because you're just playing around with the toy, what you might want to do is increase the swap. I just added a gig. So I think the default DigitalOcean small one gives you something like 20 gigabytes of hard disk. So you might as well use one of those gigs to augment your RAM. And that just makes sure that your server doesn't crash if you're getting a bunch of activity or something like that. If you just Google add swap to Ubuntu, there's a million tutorials, but it's essentially these 3 lines. The other things I did, I'm going to get into in a second, but first I'm going to show you the beautiful website that we are going to be playing with today. So it's available at talkshop.name. If you want to pull it up yourself on your own app, you can already see what's going on there a little bit. If you want to see the code itself, it's available at github.com/OKWME. That's my personal account /talkshop. I pushed a couple little tweaks just today, but most of this is quite old. Doesn't really matter. Most of the ideas still stand. And what's really nice is that I augmented this code base with a lot of the stuff that's installed on the actual server. So for instance, I put in the Nginx file. This is where it describes using this beautiful domain name that I got to access your actual blockchain running. So just to zoom out a second, the architecture here that we're working with, maybe I should write this down, is such that there's this front end, right? The front end is the one that's at github.com/okwithme/talkshop. And it's a Vue.js app, and it has a Lambda function called faucet. I'm using Netlify to deploy. Let's look at that really quick. If you're not familiar with, Netlify, it's a pretty slick service. It's essentially a wrapper around a bunch of different like cloud services that you integrate with GitHub. So I just say, hey, every time I push to the master branch, I want you to run this build command, and I want you to deploy it to a setting that has these features. So my deploy settings means I can do things like set these environment variables, set chain ID, set a Google authentication ID. So I'm going to show you why we're using that in a second. Also set a mnemonic phrase. So on this blockchain, I created an account that is preloaded with a bunch of tokens. And the reason I did that is because you can't play on my app, you can't use my app unless you have some tokens first. So how am I going to get those tokens in your hand? I'm going to set up a faucet. And that faucet, if it were just completely unregulated, you'd basically be able to drain the faucet really quickly. You can basically still do that, but now you have to do a Google CAPTCHA every 30 seconds while you're going through that process. So it makes it a little bit more annoying. That's taking place here. And you can see in the bottom right here, it's protected by Recaptcha. And so you would just put your wallet address in here and set enter. If Google thinks you're okay, the Lambda function would generate a transaction that transfers 1 token to that account. And afterwards, you would have, enough name token to start interacting with the application. Let me go back to this little diagram. we use Google Captcha, Netlify deploy, sorry, Netlify Lambda function faucet uses Google Captcha. So I'm going to basically go over a bit of this whole sort of architecture, and then I can either start top to bottom and sort of poke into the code in each section. If there's specific pieces of this that you guys are more interested in than others, please speak up so I know to spend more time on it or less time on other things. Set environment variables at Netlify. That's really nice. There's also this DigitalOcean server I mentioned. That's another sort of top level. Cheapest, increase the RAM through swap. It uses Nginx to handle domains. I bought a domain, which is talkshop.name. However, I want talkshop.name to actually show the front end. So in my DNS, I point basically the root domain to this IP address that Netlify controls because they're deploying it for me on some cloud service that they have. So when you go to talkshop.name, you just see the front end. But I have these other instances running on DigitalOcean server. You know, I'm running my daemon, which is the actual app. And I'm running a REST server, which is what the front end asks, like queries basically, when it wants to know what the hell is going on in my app. You could use, wait, what did I call it? Was it UFW, UDP? UFW. You could use UFW to secure ports. Not doing it right now, so please don't attack me. I can show you a little bit what the server looks like and how you might run commands, persistent commands on the server. And then the other part is actually SSL. So, or I can say HTTPS. So you can either use Let's Encrypt, or you can use a really sort of fast and dirty solution, which is Cloudflare. Then inside the actual app, let's roll back to that a bit. We are querying, querying all names and querying all who is info. We're doing this in a recursive REST request. Very soon, you'll be able to do this with WebSockets. You currently can do it with WebSockets against the Tendermint endpoint, but it's not going to come back in as easy to manipulate format as it would when the REST is completely enabled. I could also be wrong, and WebSockets are available in the REST endpoint already. I've just never used them, but we're not currently using that. So that's sort of an advanced architectural decision you'd be maybe excited to get into. So without further ado, I'm going to go back to the site and sort of show you what's going on here. So if you haven't already, you might want to, actually, before I go into this, you might want to go to the SDK name service tutorials. If you were to clone this project, you can use, of course, this lovely copy pasta, git clone, git GitHub Cosmos SDK tutorials, change directory into name service, and then just run make install. You can see this is the basically final command, build run. If you don't have your Go configured correctly, this is a little bit of help to make sure that Go is installed correctly. Otherwise, you would just clone it, change directory into the name service tutorial, run make install, and that would put name service daemon in SD and name service CLI and SCLI into your path, which means that you can access it just by running those commands like that. Putting the help will sort of prove that you have it available. That's essentially what I did on this server. And so I will show you the server. let's look at this one. Did I drop out of the server here? Where, oh, I did, didn't I? Okay, I want to go back. So here I am in the root of my server, and inside of SDK tutorials, inside of name service, I ran make install. I'm not going to do it again because it already built me my NSD as well as my NSCLI. So in my root folder, in order to actually run the process persistently, what I did was NSD start, although I put that inside of a file called daemon.sh. It's really pretty simple, it just says NSD start. In order to run it persistently, I did /daemon. I also wanted to know what is happening inside of this command, so I wanted to port out the logs. A simple way to do that is to just run the sh command with a little arrow sign, and then the name of the log file you'd like to use. So I'm using daemon.log. And then if you put an ampersand at the very end of that, it will close out the command, so it's no longer taking over your session. It's running in the background. That means that NSD, the process, is just running in the background. So if I were to run, say, htop, you should be able to see it somewhere in there. NSD, right here. NSD start, still running. And if I wanted to know what was going on there, I can use tail.f on my daemon.log file. And here you can see the most recent output. This is the actual Tendermint client showing me every block. So every time a block is produced, this shows up. You can see the new height, that's the block height. There were no transactions in this block. Here's the new app hash. There were no invalid transactions. There were no valid transactions, blah, blah, blah. So that's a way that I can sort of check out what's going on. I did a similar thing for the REST server. So there's a file called rest.sh. I'll look in here really quick. It's a pretty simple command. The REST server comes out of the command line interface. So that's NSCLI, REST server, --. And then this is where I say, where do I want to broadcast this REST server? By default, it goes to localhost 1317. However, I want other people to be able to access this. And so in coordination with my Nginx file, I broadcast my REST server at 0.0.0.0 port 1317. And then inside of my Nginx file, which we can take a look at, which is part of that code base I mentioned earlier, this is okayWithMe/talkshop. You can see that I'm broadcasting on port 80, node.talkshop.name, and that is getting redirected to localhost 1317. That is the actual Tendermint node. And here I'm doing CLI.talkshop.name. So this is the REST endpoint, and it's going to 000.26657. Sorry, swap those back. Swap what I just said. The node is what the website is talking to, and the CLI is if you want to actually from your local machine use your command line interface, you can point it to this domain and you'll be able to interact with it from your local machine to my remote machine. So we're going to get into doing that in just a second. Meantime, we're back here. So we've got this REST server. I will start it in a similar capacity where I do .rest, and then I port it into this rest.log file so that I can keep a track of it. Then I put a little ampersand at the end, and that will run the process in the background. And now I can do a similar tail.f to the rest.log, and that will show me what's going on with my REST server. So this is the different queries that have come in here. There's a bunch of queries of /name service /names. So that's just saying, give me a list of all the names that exist. And then it queries a specific name. That name is Billy, and it asks for the who is information of that. So let's jump back to the front end, and we'll get a little understanding why that's happening. So you'll land here, And you'll see that there's sort of this giant text box, welcome to talkshop.name. This gives you some commands that if you built that command line interface locally, like I mentioned just a minute ago, if you cloned the name service repo and then you ran make install, you would have NSCLI locally. So if you wanted to, you could create your own key locally. And one way to do that is by copy and pasting from here, but first you might want to put your own name, and that's not working. This was a feature I tried to add today and Vue yelled at me. It said it wasn't properly reactive, but you can edit inside of here. So my name is going to be Alice today. So NSCLI keys add Alice. That'll locally generate a user account for you that has a public-private key pair. And then if you're going to be using the CLI, you might want to set some configuration for it. We know we're going to be talking to a chain that has chain ID name chain, so set that. Otherwise, later on, you're going to have to include it all the time as chain ID name chain as a flag. But if you don't want to include it as a flag every time you do anything, you can just set it once and forget it. The other thing you're going to do is you're going to set the node that you're talking to. By default, your command line interface will look for a local instance of a running blockchain. And you're not running anything locally because we're all trying to talk to the one that's on this server. So you can point to it using config node. You say it's at http://cli.talkshop.name port 80. You also might want to configure the indentation of your results if you want the CLI to print something a little bit prettier. And the last one is trust node. This is just a command you need to have to let the command line interface trust the results from this node. Typically, you would be talking to your own node, so it's fine to do so. We're basically doing the same thing here. Here's some example queries. So once you've got your name, what do we call yourself, Alice? You would maybe want to know about yourself. So if you query the blockchain and say, hey, tell me about Alice, you're going to get an error because Alice has never interacted with that blockchain. It's never owned tokens on that blockchain, so there's no record of it existing. This is slightly different from the way Ethereum handles a query that says, tell me about this account address that you've never seen before. Ethereum just says, oh yeah, I didn't know about that, sure. He just doesn't have any money because all account addresses theoretically like already exist on Ethereum. That's simply just because of the way their query responds. Totally possible to make a Cosmos chain respond this way. I don't know if it's desirable or not because it means that you might run into some problems in other modules which expect the account to already exist in the key value store. So even if it doesn't have tokens, you know, it can exist. Whereas from the beginning, it doesn't exist yet. Anyways, that's basically the reason why you would want to have something like a faucet so that a query can get instantiated. Basically, you need tokens in order to pay the fees that get it included in a block. Otherwise, somebody could just spam your blockchain by sending a bunch of nonsense transactions that cause state bloat. But when it comes to onboarding, say, non-crypto native people, it gets a little bit weird to like jump through this permission system of having tokens. So there's also ways around generating user accounts without giving them tokens. But the simple way is just put some tokens in their hand. So once you ran this query account and you realize, hey, I don't even exist, you probably want to make yourself exist. So one way to do that is by getting a hold of your address. So let's look in here again. This is my local machine. Actually, maybe it's easier to read like that probably. So I just installed NSCLI locally. I can run help command. It's not helping very much. And you can see, oh, you want to use an NSCLI. This is all the stuff that it can do. Great. So I want to say, what are the accounts that I have already installed locally? You can do NSCLI keys list. Great. So I generated one called Alice at some point, and I generated one called Jack at some point. That's great to know. So you can also see my config file where I already set all this stuff I just mentioned. I set name chain as a chain ID. I set true for the indentation. I set the keyring backend to test. So this is something that I didn't go over earlier, but this is whenever you create a new user, so NSCLI keys add Bob. Generated a new account Bob. Here's the address, here's the public key, here's the mnemonic phrase for this new address. Whenever you do this, you have the option of saving these keys in some format. And the formats are, let me run help, and we can look at the keyring backend. So the options are OS, file, and test. OS looks for your current operating system and uses the default keyring that your operating system uses. So if you're on a Mac computer, you are probably familiar with the keychain. If you ever had to share Wi-Fi with somebody or something like that, Mac has this dedicated private key management system. So if you were to use OS, which is the default for your command line and generating a key, it would let your actual Mac computer manage, store, and access that private key. So if you were to turn around and run the command line to generate a message and submit it using that OS keyring, you might actually get a system dialog pop up that says, hey, are you sure you want this program to use this key? And then you have to manually click the OK button. So because that doesn't jive very well with combining commands in the command line, because it requires an actual mouse to like move over a button, you might decide to use either file or test. So file stores the keyring inside of your home directory. So whenever you build one of these binaries, it adds a bunch of config data in your home directory. In our instance, it's NSD with beginning with the period, where we can see here this config data logs, as well as home directory NSCLI. So here we can see there's a keyring for a test name service. That's where it's storing the third option, which is test. So the first option, file, goes in here, but it's encrypted and it's securely stored. The third option, test, is it just throws it in there in plain text. It's really low security, but it means that it's really easy to access it. You can also see that this config file, how do we get back in? What are we in right now? We're in NSD. I'm going to go to NSCLI just to show you that the config here is in a TOML file. And that's also where you can find your CLI configurations that we did earlier for the chain ID, the keyring backend, what the node ID is going to be, and the output, et cetera, et cetera. So with that all in mind, I'm going to go back to SDK tutorials, name service. Actually, you don't need to be in this file at all because I already have the NSCLI stored. But I'm going to find out what my address was. Right, that's what I wanted to do because I want to see if I have any tokens on this application. I see your question, Rhett, and I will address that once we get to the front end. It's a great question, though. It's about whether there's anything like MetaMask or browser plugin wallet to interact with the app. So I have a really exciting plan to address this issue, but we'll get on that in just a second. In the meantime, we're going to find out if our account, and again, if you've installed the name service locally, you can do this for yourself, find out if your own account has any tokens. We're going to do that with a query. So you can either write Q or the whole word query, account, and then we can use a sub command to show Alice and just list her address. So before we do that, why don't we just show you what this sub command does. NSCLI keys show Alice. Without the A, shows a whole bunch of information. With the A, that will show you just the address. It's basically a shortcut for saying flag, address. You can just do it as one small a. So now we can go back to our tell me about the actual contents of this account, which is NSCLI Q account, and then this subcommand NSCLI key show Alice A. So now this queries the node, which I configured to be the one running on my DigitalOcean server, and it returns, hey, look, I know about this account. It has one name token. That's because I already took this name token, this account through the faucet. Let's do the other account we have locally. We did Jack was one. Unknown address account blah, blah, blah does not exist. Jack has never interacted with this blockchain and has no idea who he is. So why don't we fix that? Why don't we copy this address and bring it over to our faucet? We can paste it in, hit enter, and we get challenged. They think we're a bot. Obviously, we've been doing some fishy activity. Oh my God, they really think we're a bot. Okay, let's fill in all this crosswalk stuff. Now it's submitting. No! Okay, that makes me think something's wrong with my blockchain. So I'm gonna go back into it and I'm gonna tail F. What is my blockchain called? Daemon.log. What do we got going on? Nothing looks out of the ordinary there. It's still producing blocks. Maybe we look in our actual network panel and try it one more time. Oh God, traffic lights, traffic lights, traffic lights. Faucet gives a 500, cannot read property value of undefined. That makes me think that Netlify might not be using the most recent deploy. Let me trigger a deploy. So it deploys the site. I made a small change to the faucet. Could be what's happening. So if you haven't seen Netlify before, this is what happens when you tell it to build. We can look again at the build settings. So it knows this is the repository. Here are the build commands. I have this Lambda function, which I want it to build. And then after it builds that, I want it to actually build my app, which I use yarn for. So I just combine those two in the build command. That command will publish the actual application inside the distribution folder, the dist. The logs for this app are public. So if you go to my repo, you should be able to click the Netlify link and you can see the public logs. The builds are active. Production branch is master. What's also really cool is that it'll actually build and deploy your app on every branch you tell it to. So if you want it to be all of your like working ones or maybe just your develop app, you can have a whole setup there. It's kind of cool. Netlify is amazing. They're starting to crank up the pricing because they've been free and wonderful for so long. So use at your own discretion, but I'm generally a fan. Okay, so this is the one we just did. Let's see if that improves our situation at all. Otherwise, I'm going to deploy this locally and we can really open up the guts of the faucet and get to understand a little bit what's happening there. Here's the wallet address. Of course, I have to click the traffic lights again. Submitting, faucet's 500 again. So, really quickly, let me just make sure that this has nothing to do with being Jack, which it shouldn't. Oops. So if I were, for instance, to submit Alice, would you still be mad at me? Alice, do you have more money now? No, same amount of money. Still mad. Okay. Well, that's all right, because we have this application locally. It's okay with me /talkshop. Here's the file. And to start it locally, you want to do two things. First, you want to actually run the Lambda function. So let's look inside of our package.json. We have at least scripts. So dev is the command to launch and run the Vue.js app, which is very similar to React apps. I find it to be a bit more legible. And the other command that's interesting here is Netlify. So Netlify will compile and run things that it finds inside this Lambda folder, which is what I told it to do, and then serve them. If we open up what's inside that Lambda folder, we'll see this file called faucet. And this is where I generate a wallet from a mnemonic phrase that I have stored inside of the environment variables. I find the address of that wallet by creating the address with the public key of the wallet. I also set the REST endpoint, which is in my environment variable. That's the one who tells me to talk to the DigitalOcean server. Here's where I set up the Google Recaptcha. So if you've ever used CAPTCHA before, you essentially attach it to your query. It goes to a little bit later. Let's see. This is what the actual Lambda function looks like, though. You export this handler. If you ever use something like Express, JavaScript web app, web server, it looks really similar. This is the function that gets triggered every time somebody talks to this endpoint. That comes with an event and context. We're not going to worry about context, but the event will tell you, for instance, what is the HTTP method? It's a post. If it is a post, great. Let's go next. We also are expecting to have a body. There's a body. Great. Proceed. Now let's grab that body and let's parse it as JSON, and we can log it out. I'll show you what that looks like in a minute. Inside, though, you should expect a recipient. This is who's trying to get that token from the faucet account. And then we grab the Recaptcha token. So this is where we actually confirm that Google Recaptcha will verify our response. It's wrapped around in some sort of redundant looking promise stuff because we're using asynchronous commands here. But if there is an error, we want to reject it, and we want to know that that response is bad. And if that response is bad, you know, if it's not successful, like it says here, we are going to return a 400 error and say, hey, Google thinks you're a scammer. Please get off of my Lambda function. Otherwise, we're going to actually create and submit a transaction with a signature, sending it to this recipient. That function is defined a little bit later, but if it's successful, we're going to say 200. We're all really happy. Here's the results. Otherwise, we're going to handle an error and give those answers. This is the returns from our earlier sort of checks to see, is this a scammer? Let's send them a funny, nice 404. Or if they're just visiting the site for no other reason, not submitting anything, then we can show a 200 with a nice smiley face. So the submit to Tendermint transaction. Question from Nabarun Gogi. So how are you running the Lambda function? So that's something that's really nice about Netlify as well. If I go back to that interface, they offer functions. So one Lambda function actively running in production. All you have to do is basically configure your Netlify TOML file over here and tell them that there is a faucet. So this is the build configuration. This is where I was able to tell it, you know, do the Netlify Lambda build and then do the yarn build. This is my build command. And then identify that there are some functions here. And those functions are located in a folder called functions. So when you run that Netlify Lambda build, it will look inside that folder called Lambda, which has faucet, and it will build them into a function called functions. And I'm saying the word function many times right now, but that's where the sort of compiled version ends up. So very hard to read, but much nicer for actually running. And this is where I configure the publish directory is going to go to distribution. They also have this really nice redirects. So typically when you use a Lambda function inside of Netlify, it deploys it at a URL that's yourdomain.com or whatever, and then it does .netlify/functions/faucet. And that's to ensure that it doesn't collide with any of your own routing pretty URLs. But if you want to actually make one of your pretty URLs redirect to it, you can define it here. So now if you go to talkshop.name/faucet, it will be the same as if you went to talkshop.name/.netlify/function/faucet and assume a response code of 200. You also might want to add this redirect for web apps like Vue, which say no matter where you're going, always direct it to index.html and allow the app itself to handle the pretty URL routing. Does that make sense, Nabarun, or do you still have questions about the Lambda function? Cool. So I made some change here that I need to get rid of, but back over here, we are in the functions. I've lost the thread. What were we talking about? Blah, 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 blah. We were in our faucet. Cool. Submit with Tendermint SIG. That's what we were talking about. So this is a transaction. TX equals. Typically, a transaction includes information about a fee. And inside of that, you can see the amount as well as the gas. So fees are funny. It's essentially the same thing as Ethereum, except for you can pick what token you want to pay your fees in. So gas is supposed to designate what level of computation essentially takes place when this transaction gets executed. And you multiply that gas by a fee amount. However, you can also just include a fee that says like, I'm willing to pay you 12 hamburgers, something like that. So if you designate the amount in this format, it multiplies by the gas and it comes out with a total fee, or you just write standard inside the fee some claim of something. It's up to the validators to decide which transactions they want to include. So they're typically going to keep a whitelist of denominations that they're willing to accept. They might also keep locally a constantly updated price chart of, for instance, name token like we're using to atom conversion, and they're unwilling to accept, a message that's only worth 15 name token because they know the equivalent in atom is so small that they just don't think it's worth their time. But it's sort of this nice subjective decision that validators get to take while they're executing. So it means that if I show up with this sort of basically worthless name token, I can still submit transactions, for instance, to the Cosmos hub, trying to pay the transaction in name token. And that transaction will just keep getting floated around in the mempool until some validator decides to update their internal list and say, you know what, I might be willing to accept name token. And then I just have to wait until it's that validator's turn to create a block, and they'll include my transaction. But this is really nice because then you don't need to necessarily go through the governance proposal or something like that, which you might imagine a blockchain might want to do. Like, do we want to accept this new token for fees or not? It just becomes up to the validators themselves. And so if you create a project which has an interesting token, it's easier to get those transactions paid in your token accepted just by either individually lobbing validators, or if validators are doing a good job of sort of staying up to date on what tokens exist, they'll do it themselves. So that's what the fee section of this transaction is. Memo, this is like if you want to write some text in there to help you remember what you did this with, or maybe you're interacting with an exchange who requires you to put a memo in there to identify your transaction. And then your message. So what's also interesting here is you can tell that based on these brackets, this message field is an array. And that means you can actually include multiple messages in a single transaction. So this is really crazy when you think about how Ethereum works. Often there's these sort of like daisy chain interactions that you want to do, especially in DeFi, where you're like, okay, buy this, then sell that, but don't buy this unless that one's sold at this price or something like that. And you typically have to build all that logic into a single contract and let that contract execute all of those transactions in a row. If you were to just sort of sign those transactions separately off chain and submit them, they might not go in the right order. You might have to like boost the gas to try to predict which order they're going, but you don't really have a way to guarantee it. Whereas here, you can combine all of those messages, put them in one transaction, and you know that they're going to get submitted and included and executed all together in the same batch. We're only going to be using one transaction here. It's a very simple one. Message send, it's the type. The value, we just say we're going to send one name token from this address to this recipient. That address, you remember, came up at the very beginning when we took this mnemonic phrase from the environment. We created a wallet, which was a command that came from the Tendermint/sig library. And then we use that wallet to derive the actual address that we're using. This is the Bec32 encoded address of our faucet, who has been preloaded with money. So we take that transaction, and then we're going to sign the metadata. So get metadata of this address basically says which nonce is this address on, because every time you sign a new transaction, you need to increase basically the ID of that transaction as associated with your address. Otherwise, somebody could replay that transaction. So say I made a check that was pay my rent to my landlord, but that check didn't have a unique ID. That means the landlord could essentially just copy that check a million times and then submit each of them to the bank and be like, yeah, look, this is another valid check that he definitely signed because it does include my signature, but it doesn't relate to the fact that it was meant for once and only once payment. So that's what the nonce is for. And this get metadata command is using Axios to query our REST endpoint and say, hey, tell me about this account with this address. Give me all the metadata about it, basically. That's what's included here. And then we grab the value from it. This metadata includes, for instance, the chain ID. No, it doesn't. It's missing the chain ID, which is why we grab it from the environment variable. And then we sign it, including this metadata, using our wallet as that transaction. SignTX actually comes from that library, so we're not going to dig in there. The next command is verifyTX. This is nice to just sort of make sure that it was signed correctly. If it's not signed correctly, let's throw an error. Otherwise, we're going to submit it. And this is the actual format that the submitted transaction takes place. From that standard TX, we take the message, we take the fee, we take the memo, and we take the signatures, which were generated using that signed TX. Then we put it inside of a body. TX mode is called sync. So this is the format that you actually throw towards the validator set. And if it's sync, that means it waits until it's been included to return information about it. And here we use Axios, which is a HTTP library for making post and GET requests inside JavaScript. And we're going to post it to this REST endpoint that we defined earlier. /TXS. This is basically the endpoint you hit when you're ready to submit a fully signed and ready to go transaction. And it includes, as the post request, this body that we mentioned earlier. Phew. So let's look back where that submit Tendermint signature came from. We get the result. If it's good to go, we say thanks a lot. If we get an error, we say sorry, here's what happened that was bad. So while we're going to start running this locally, we're going to have to first run that Netlify endpoint so we can sort of dig in to see what's actually wrong with our command and why are we getting that 500. So to do that, we would run yarn Netlify as defined in our package.json right here. So now it is building and deploying our faucet.js, and it's putting it inside this functions.js folder. And it should do hot reload for us as well when we want it to. Once it's there, we can see it's listening on port 9000. So let's really quickly localhost port 9000. Ooh, it doesn't like this. The path argument must be of type string, received undefined, internal validators, blah, 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 blah. Lambda serve 103. Their handle, where is this actually coming from? Oh, we can see it here too. The path argument must be of type string. So what I'm thinking that might mean is that our environment variables might not be showing up. Let's see if we can just console.log process.env and see what it thinks we have. So that should recompile. I'm going to clear the buffer. Let's see if it automatically deploys it or not. Oh, it does. So entry point facet, critical dependencies, blah, 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 blah. So we need to actually hit that endpoint again to be able to see what went wrong. Path argument must be, why was this running 15 minutes ago? And it's not running now. I'm just going to run yarn really quick, make sure everything's up to date. Let's look inside of our env file. We messed something up there. So we've got this mnemonic, we've got our chain ID. That's the mnemonic for our function. Gotta make sure the process is there. And let's try running yarn Netlify again. It's on 9000. That's confusing to me. This should show this console log that's actually getting used. If the event's not post, then it should return this. Not post. Build it again. Still doesn't like it. Type error. That makes me think it's coming from the Tendermint SIG library. Oops. The Tendermint SIG library. Express router. No, this is all Express stuff. Why is that? Internal values. Is our blockchain still running? TLF daemon. Looks good. Let's see if we can TLF rest. That looks good. Our faucet is mad at us. So I imported a minute ago some Beck32 stuff to make things fancy, but this doesn't seem to be doing anything to it. In fact, you know, my favorite thing to do is to remove recursively node modules and then just reinstall all of it and hope that that magically fixes it. So let's give that a shot. Oh shit, I'm gonna force the removal of the node modules and find out what happens. Okay, let's run yarn. Linking all these dependencies. I wonder if we can get any information from Netlify functions. We've got this one going. Is it giving us, but it's running fine. What's going on? So, I mean, it's at least telling us the queries that we want, even though it didn't like it when we asked for money. Read property value of undefined. If we go back to our app, the other thing it's doing right now is querying our node. So that's where it asks for the names and asks for the who is. So we know there's one name that's Billy, and the who is for Billy is this stuff. Okay, the blockchain stuff is good. We're running into a Lambda function problem. Put some trash in there, see what it says. Cannot read property value, same. So if we look at our Lambda function, it means that it's asking for the value of something it doesn't know. And the only place that it's asking for value is in our signed metadata. So it's trying to get metadata of the address, which makes me think that the address doesn't exist, which makes me think it's using the wrong mnemonic phrase. Maybe that's what's going on. So the mnemonic phrase that's happening, that's being used inside of our app, it's inside of our deploys, deploy settings, scroll down, and our environment variables are here. So let's edit the variables and look really quick. Mnemonic begins with order release. Let's look at the actual server. NS CLI, oops, CE, NS CLI, keyring test name service. So faucet, that's our private key encoded in a weird format. We don't care about that. Let's do NS CLI keys show faucet. So the address that comes out is Cosmos 1232. It would be great if we could see what does the transaction look like that's getting submitted that fails. Let's see if that's in here. Recipient here. Recaptcha token. So that's what comes through. That's fine. Somewhere around here, we say we want to send it from some transaction. We're not seeing it. Let's take our faucet address and run ns CLI q count and make sure, yep, that's our faucet and it has a bunch of money. Should be the one that uses that same mnemonic phrase. Inside of our environment here, order release Scorpion, that's the same mnemonic phrase, right? Inside of our environment, there's order release Scorpion. Huh. So when we get metadata is when we might be getting that error, but let's just try to get the metadata ourselves. So metadata is a get command, REST endpoint auth accounts and address. So let's do node.talkshop.name/auth accounts. And then what's the name of our faucet? That looks like it's coming back fine. Result.value should equal something. Get metadata, returns response.data.result, response, .data.result, and then we pull .value out of it. So we could log that there. And we could also log what our TX looks like. Now let's quickly just see, what have I changed? That's the build version. So I added some crap there that's unnecessary. What else did I change? Not post, we don't really need that. Here we go, we're logging the TX now. And we added back this log here for the response. So if I were to add this to the repository as a debug, oops, add with a message, push it, it should rebuild on Netlify, and let's see how it deploys. It is building for us. I'm always confused if this build guarantees, yeah, creating functions prep folder. Cool, this build will also rebuild the functions. Installing dependencies, blah, 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 blah. I'm still spooked out that we weren't able to build the Netlify Lambda function locally. Why weren't we able to do that? Yarn Netlify, come on, build for me. Don't yell at me this time. Really doesn't like me. I wonder if this has to do with the fact that we're not actually querying an endpoint that it knows. I could always just Google this error as well. Ooh, somebody's got it. Happening in React. Delete your node modules folder and rerun. I might have been onto it, although it didn't fix our problem. Weird. So this is some middleware config error that I haven't seen before. Aha, it tells me to remove the package.lock JSON as well. Let's try that. rm.rrf, node modules. And then we're going to remove yarn.lock. Now we're going to run yarn. Okay, in the meantime, we're going to go back to the live deploy. Hopefully they're having less trouble than we are. So this should be deployed now. Site is live. That's great to hear. Let's go to the live one again. Talkshop.name. And let's take our local one. Who are we going to talk to? We're going to talk to Jack. NSCLI keys show Jack address. Here it is. Actually, let's make sure that he doesn't have money yet. NSCLI Q account Jack A. Cool. He still doesn't exist. So let's try to get him to exist by sending some money his way. This is the account address. What's going to happen? Ooh, faucet did not throw. Faucet did throw an error. Still can't read property value of undefined. But now, hopefully, we've got some debug logs. Where are we at? Where are we at? Here we go. So let's go into our functions. Faucet was deployed 2 minutes ago. Here we go. What are you telling us? So here's the transaction. Info undefined type error can't result. That's not. Our response is successful. Why doesn't it like us? Info undefined. What is the info part? Faucet.js line 121. Let's look there. 121. Verify TX is what's throwing. Is that right? I wonder if Tendermint SIG has updated since I made this. And when I was trying it earlier today, I was using the older version. This is something that's possible. Okay, so our TX went here, signed metadata here. Let's just say success. We did the metadata thing. Let's log our signed transaction. And now our status code of 500 should return in the body the standard transaction. Makes me think this is not an accurate error. But my favorite way to debug is just by putting console logs all over the place. Hello, why do you hate me? Hope you all can identify this. The fateful hello 2, the fateful hello 3. Put them everywhere and have a great time. Let's also check on how our rebuild is doing over here. So now if we were to run our Netlify again, and try to accessing this. Ooh, it really doesn't like us now. Our Netlify, starting server, and faucet, module build failed. Plugin preset files are not allowed to export objects, only functions. Wow, we are in the middle of a Babel Webpack error. No, we're not. Name the server is listening on 9,000. Let's see if it really hates us. Refresh. You've requested the root of HTTP localhost 9000. This is likely a mistake. Netlify Lambda serves function at localhost 9000.netlify. Your function name. Please fix your code. Cool. So let's try that. And our function name is Lambda. Error cannot find module Lambda. No, what do we call it? Faucet, of course. UCDT. Hey, look at that. We have the little smiley face, the 200 smiley face. Okay, so now we're moving, and now we have our request is showing there. So now, once we've got our Lambda running locally, let's actually run our app locally as well. So that command is yarn dev, and that will launch it at localhost 8080. Hope you guys are just as excited as I am that we got through that first bug. Let's see, local host 8080. TalkShop, man, that is very large. Let's zoom out a little bit. We'll open up the console so that we can get a better read. Get out of here. Elements network. Great. We just want these. Oops. And let's grab that address again. Where do we get him? Might need to split him up again. In SCLI keys, show Jack. There he is. Poor Jack. Not getting any money from the wallet. Okay, oh God, of course we have to tell them the bridges. Bridge, 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 bridge. Faucet. Thank you, you've received some name token. Thank you, that is what I expected to happen. So I wonder if this whole little rigmarole we just got into with our package JSON and all this build problem is what got transferred to the live server. So now if we were to say NSCLI Q account, show Jack, boom, Jack exists. That's amazing. Okay, so we're back on track. So has anybody attempted to actually build the CLI locally and interact with this live blockchain? Anybody at all? Anybody at all? Going once, going twice, going 3 times. You're just riveted by me doing it instead, right? That's what you're here for. Great. Well, if you had been doing it, you would now have the opportunity to start buying names or start stealing names from someone like me. The really sort of cool thing that I was hoping to display at the end of this, I know we're coming up at an hour and a half. Everyone's just glued to their seats. Is I wanted to actually use the name service as a name service. So just quickly to demonstrate buying one, let's do this for Jack. So actually we can use the instructions here as well. So earlier we made a new key, we made it for Bob, but actually let's see if this works here. Bob, nope, doesn't work. Bob is how you make it, and you get to decide, are you gonna use the key solution test, because we already set that config, which is what I suggest you do. Set all your other configs, the nodes, the indent. Then you can query your account. You find out that you don't have any money. You can either send some money because you're somebody who has money and somebody who doesn't wants it. We're not going to do that. We're actually going to use the wallet. So now we did that. Jack's got some money. Now we want him to buy a name. So the domain that he's going to buy is going to be, let's say, jack.com. And he's going to spend 1 name token because he only has 1 name token. Name is Jack. We already did that. And again, you can use this sort of long form of address or the short form of A. I'll do that. I broke it up into 2 lines, which is why you have this backtick there, just so you can read it more easily. So I'm going to copy this and try doing it locally and see if Jack is able to buy the name Jack for 1 name token. I configured the node, so it should be pointing to the right place. Here we can look at the transaction before we sign it. Chain ID looks good. Account number is 8. Sequence is 0. Fees. Gonna do no fees basically. Luckily the validator we're running will accept no fees. And the messages, we're gonna do the buy name. The name's gonna be jack.com. The bid is 1 name token. Use the buyer, here's the memo, looks good to me. Yes, let's do it. That's the transaction hash. We can either query the transaction hash like NSCLI QTX and then write it in and see, here's all the information about it. Did it get included? Did it trigger some events? Looks like it's pretty good to go. You can also just jump back to that front end and look at the names. So if we want to see how did that show up, let's jump into the code really quick of the Vue.js app and look in the hello world file. This is not what we want to look at. This is where we're actually submitting the Google CAPTCHA. This is the form that actually uses the faucet as an endpoint, and it includes that Recaptcha token as well as the address that came from that form. What we want to look at are the names file. So this, if you're not familiar with Vue, it basically looks like normal HTML, and then you set up a script below it to make it reactive. In this scenario, we've got a div that is going to repeat this div for every name inside of names. Names are coming from this data object. And we need to populate this array of names. So when this component is mounted, we are going to check for names, and then we're going to set an interval for every 5 seconds in which we check for names again. So let's go to the check section. Check loading equals true. So this is loading equals true so that we know if you're currently querying the endpoint, you're not going to try querying it again until this one is done. And now we run the query against this node that we have running, and we ask for a list of all of the names. And then we take that response, we set loading to false. If the response length is equal to 0, then we just stop what we're doing. Otherwise, we take the results out of data, and then we check names. After we set, this dot names equals the result, that will update this array here, which means that it'll immediately loop through them and display them as the name here. And then below that is the who is data. This is where it shows the meta stuff. However, who is, which is also defined here, hasn't been populated at this point, so nothing's going to show up. Oh, Marcel from Blockscape, cannot read property value of undefined. I can't get token. Okay, will you paste your account address in the chat? And also let me know, are you trying this against a local build of the front end or a build on the talkshop.name? I'm waiting for a reply from Marcel from Blockscape. If I don't get a reply, I'm gonna keep plowing through, but I wanna help you get some tokens. Okay, Marcel, if you come back, let me know. I'm gonna help you get those tokens. So this is the check, right? This is where we populated the names array. Once the names are filled, we're gonna try to get all the who is. So that's what check names does. And this has a loop that goes through the length of the names, and for each one, we run check name of the integer, the index of it. Check name index means check name loading is equal to true. We're gonna, I started using console.time to sort of check how long these requests were taking. I know this is a pretty inefficient way to do it, and if we had WebSockets open, we wouldn't need a poll like this. But it takes the name from the names array based on the index, to make sure that each name gets queried once. We take the response from a GET query in which we say, tell me about the name service names, specifically with this name, give me the who is information. And then we update that who is object using the name as the key and the response data as the value, and we set loading to equal false. So then we go back up here and we can see once that who is populated, it'll start populating the value, owner, and the price. So if we look at the actual web app, we can see that for Billy, where there is a value and an owner and a price populated by the who is, inside of Jack, all they have is the owner and the price because the value hasn't been set. So let's go back to our commands and see if there's a set name. Here we go. Format for that is going to be nscli.tx name service, set name instead of by name. We're going to say what's the domain that we're using and then tell it what value. We're going to say who it's from as well, because nobody besides the owner is allowed to set the value for that domain. So for Jack, we're going to set a value. We could set it to anything. We could set it as a C name. We could set a JSON object that included whatever. I would like to set it as Jack's actual address. That way, if somebody wants to send tokens to Jack, he can just tell them, send them to jack.com. So let's go back to our command. We know that Jack's address is here. I'm going to keep that in my clipboard. We're going to do nscli tx to let the command line know that it's a transaction. We're going to do a name service transaction. We're going to do set name. The name is Jack. Let's see, we can look at this format. Jack.com, and then we're actually going to set the value to be his address. And we're going to say transactions from Jack. Here we get a preview of it. Looks like pretty good to me. Message includes set name. The name is jack.com. The value is this, and we're the owner set there. So I'm going to say yes, please proceed. We have the transaction hash. We can do nscliqtx with a transaction hash, and it'll tell us all the information about that transaction. Looks like it got included. Looks like it triggered some logs. All good. That's exactly what we want to see. Now we can run back to the front end. And if we go under names, we'll be able to see that the value for Jack has been updated. So the reason I wanted to do this is because we have this place already where using a domain name like jack.com, or in this instance, just straight up Billy, can help us in our user experience. Instead of typing in this long, crazy wallet address like you're seeing here, why don't I just write jack.com and be able to transfer tokens that way as well? In order to do that, I'm going to have to modify my Lambda a little bit. So let's jump into our Lambda again and see what's going on here and how can we improve it. So remember earlier we got the recipient from the body. Typically we'd expect that recipient to be a bec32 encoded address, probably something that begins like Cosmos 1 and then a bunch of alphanumeric characters. Remember that Cosmos 1 is the prefix for the address type, and that's an option that can be configured per application. So if we wanted to make a whole new subset of addresses that began with name service, we can make addresses that were checksummed that way with bec32. It's really up to the designer of the app to make that decision. We're just using the default, which is Cosmos for now. So it comes in as this Cosmos address, but we want to see if it was not given in that Cosmos address, say somebody put in something like jack.com, how can we find out what the address associated with that name is? So first let's find out if the thing that came through is a valid bec32 address. We can do that using a library called Cosmos.js, which I mentioned earlier. So Tendermint SIG is really great, especially for the live app, the live Cosmos Hub right now, which is running the SDK version 0.37. Since that, there's been the release of 38 and 39, which are essentially the same, but 39 is the long-term service release of the SDK. And also what's coming out soon is version 40. Those are going to be much better supported by this library Cosmos.js. And Tendermint SIG will eventually be deprecated and combined with the efforts inside Cosmos.js. So I'm already sort of starting to pick some of the usage from it. One of the things that are really nice from this library is a sub-library about encoding. And there's a command inside that gives you a lot of access to bec32 manipulation. So I just want to find out, is that recipient address bec32 encoded? By doing so, or I can find out by trying to decode it. This command will throw an error if it gets something that's not bec32 encoded. So I'm going to put it inside of this try catch. If it comes through and it's already in bec32, I'm going to log it out and basically let it run. You know, that means the recipient's already in the correct format. Everything should work as it's supposed to. Great. However, if there's an error, that means it got something that didn't look like bec32, which might be something like jack.com. So I'm going to log that error just for my own purposes, and I'm going to remind myself that I need to resolve this. Can we figure out if that name actually already has been registered as a domain and if it points to an address that we can use? So I made a new little function called getValue. GetValue takes the recipient, whatever that text is that came through our form, and it will query the blockchain to see if there's already a name resolving for it, and it'll return it if so. At that point, I will try to decode it again, and if it decodes into a valid bec32 address, then I will be very happy. If it doesn't, then it still doesn't work, which means I will throw an error and say, hey, quit trying to throw me this trash string. I'm not going to send tokens to this trash string that you're trying to send to me. So let's look at this function really quick, getValue. Also commented it out, but it's pretty simple. It's using Axios again to make a query against our REST endpoint that we have running on our DigitalOcean server. We're using this name service names, and we're actually just asking for one specific name. That one specific name will return as a value. And if that value, you know, that's what we're returning back. We're saying, hey, there's a record here of this value. What do you think about it? If it's something good, it'll be happy. If it's something bad, it won't be. Excuse me. I have a feeling this probably will make an error if you try to query a name that doesn't exist. The response is probably not going to have a result, which means get value is going to throw an error. So really, I should put this in here so that if this does throw an error, the same still need to be resolved is going to be triggered. Otherwise, it might shut down my Lambda function. Great catch, you guys. You've been my squeaky duck for this. So let's see if that works. This is our Lambda process. It's getting mad at me for something. Something to do with Babel again. Let's hope if I just cancel it and run it again, all my problems will go away. Oh yeah, this is the error that doesn't matter. It's yelling at us, but at the end of the day, it still says Lambda server is listening to 9,000. That's what I like to hear. So I'm gonna clear that buffer again and go back to our, whoops, local. Why did it do that? I didn't want to do that. There we go. Go back to our local instance that has this new updated Lambda function. Just going to refresh so that the console log is a little bit clearer. Now we know that there's some names over here, right? We've got Billy and Jack. Let's try to get Jack one more token. Now that we have his name, submit, and we get some stairs. What are the stairs? Okay, we got some stairs. You happy with that? No, bad request encoding Bec32 failed, invalid index of 1. So that means that they submitted our transaction to the blockchain with Jack as the name. That's not what we wanted to do. Let's scroll up here, try to figure out why it did that. Here's the transaction, recipient jack.com, doesn't like that. Here's the transaction, here's the type, here's the metadata, here's the message again, from address to address, jack.com. Why would it do that? We really don't want it to do that. Looks like it's maybe not using our new version of the faucet. Can we say something like, using Bec32 now? And up here, let's make sure it's doing it by saying something like, please use Bec32 now. Go back to our Lambda, cancel it, run it again, yelling at us, we're still on port 9000. And let's try it one more time. Here's the console. Fingers crossed, jack.com, submit. Bad request, Bec32 failed. So our Lambda doesn't seem to be getting updated for some reason. We've made the changes. Why don't you like us? Still trying to send it to jack.com, and we know that doesn't exist. Obviously that doesn't exist. I wonder if it does have to do with this Lambda, that it's only using the previous file. Maybe we should try to cancel. Let's remove the built version of the function, which is inside of functions faucet. Functions faucet. So got our Lambda version. Oops. Didn't mean to mess with that. SJS is deleted. Our Netlify one more time. Ooh, here's a really bad one. Cannot find module. Functions faucet. Build failed. Okay, so it was failing the actual build. Plugin preset files are not allowed to export objects and their functions. Means it was using the old version of the faucet. So why would you do this, JavaScript? Should we use our trusted remove RF node modules and remove yarn.lock and then yarn install again all at once? Let's see if that works. This app is going to freak out because it loses all of its yarn modules. It's a race against the clock. We have 12 minutes left, 11 minutes left on the hour. If we can successfully improve the name service app to resolve names within the next 11 minutes, we will have done the impossible. We will have gotten through NPM hell, which, as many of you know, is the furthest ring of hell. Okay, so it's been installed. Let's see if our Netlify still hates us. Still hates us. Cannot find module. Functions faucet. Because we didn't build it. And the build failed because Netlify Lambda node module Babel loader libindex doesn't like us. Why do you hate us? Do you think it's worth pushing this to the server? Probably not, because then this problem will just happen on the server. So this makes me want to pull out my hair. I mean, it's still running on 9,000. How is that possible? Let's open it up. Local host, 9,000. What do you tell us? Oh yeah, what do we actually want? Netlify functions faucet. Functions invocation failed, cannot find module right. So it's not there because we weren't able to build it. Marcel, are you still there? You want to try to get your token? Hey, he's back. Okay. Would you paste your address inside the chat here? Okay. So what I'm going to first do is use my nscliq count. So I know your address, I'm going to paste it in. Great, doesn't exist. Let's see what happens if we go to the thing directly and paste your name in, submitting. First, we got to fix the crosswalks. Not that this is going to work just because I did it, but it's the first thing I have to do. Now we have to, which ones are tractors? Okay. Is Big Rig a tractor? It's not. Cannot read property value undefined. Woo! So let's look inside our faucet and try to understand their why. Oops. This is the recipient, right? 13LL. Is that the one you gave me? Yeah. Okay, so we're back in the same problem we just were. And when I built locally, it fixed the problem, which makes me think that it has to do with some Axios dependency or something like that. Although now I've put ourselves in the pickle that my local version doesn't like us either. So we're not going to be able to push that. We are in a pickle. What I can do is use my local command to send from Alice has tokens here, from Alice to Marcel's address, one name token from Alice. Yes, I want to broadcast that. Did that work? NSCLI QTX. Looks like it did. Marcel, you have a token. That means that you can now use your command line to purchase a name. Let's all give them a drum roll. If you are able to do this, it will show up automatically here because I'm polling the blockchain every 5 seconds. Is that something you're willing to do for us, Marcel? If so, I will begin the drum roll. I don't know how long I'm supposed to do drum rolls. It's really hard to do. No pressure or anything at all. You have 7 minutes maximum to do this, and then we can still talk to Rhett about the wallet situation. Actually, why don't I do that, and we can just keep on standby for Marcel's name to show up. So Rhett, are you still there? Give me a chat. If you are, I'll talk to you about this. Otherwise, I'll talk about it anyways. Great. Cool. So typically in the Ethereum world, you're probably used to the idea that you'd want something like MetaMask available, where you would point it to your, you actually, you know, depending on which network you're on, you assume you're going to be on mainnet Ethereum, you would use something like Web3 Connect or Modal Connect to try to find the Web3 object inside of your dApp. And then the Web3 object would just relay commands to whatever provider was giving you that Web3 object, and that provider would do the signing actions. So that functionality is going to be available inside of Kepler in the next release. And that's especially exciting because you'll be able to point to any node of any blockchain, and it'll be able to tell you the message types that are available and let you sign them there. It'll do the same, excuse me, for Cosmos contracts. Now, prior to that, what is available already is if you are using Ethermint. So Ethermint is the EVM module for Cosmos SDK applications, where you would more likely redeploy some sort of series of contracts that you were using on mainnet Ethereum, except for you want them to be in a setting where you have complete control over like the gas usage and things like that. If that's your situation, that will produce a Geth RPC endpoint at port number 8545, which should be completely indistinguishable from any other Ethereum Geth endpoint. So if you're familiar with the MetaMask flow, you would just go to add a new network. You would point it to the IP address 8545 where your app is running, or localhost 8545 if you're running it locally. And then you would have full use of MetaMask in the same way. So that's specifically for EVM stuff. So that's not crazy different or crazy exciting. You're probably used to all that. What is crazy exciting is coming up all of the use for Kepler to do that stuff. However, I am even more excited about a future world where things are even less complicated. And that world I spoke about a bit inside of a forum post called Cosmos Hub as Universal Wallet. And that one sort of goes full expanding brain on it, but there's like less expanding brain versions of it that I can get into. The huge one is a combination of interchain accounts with subkeys, utilizing the Cosmos Hub specifically to be like a surrogate representative of an identity for every user on every other blockchain. But to like decrease the expanding brain a little bit, something that I think is actually much more exciting is separation of a wallet and a private key manager. Thank you, Adriana. There's a link to it for everybody. So typically wallets are trying to be both, or they're trying to do sometimes 3 things, which is they're trying to be dApps themselves. They want to show an interface that basically allows you to interact with a blockchain. Something like Argent, you know, has really, really well-made integrated interfaces for all this. Hey, we got Blockscape.network. Woo! 4 minutes to spare. Congratulations, Marcel. Let's see if you can set a value while I'm still talking about the expanding brain wallet world. Yeah, typically you see a dApp interface that a wallet's trying to do, you know, just by augmenting certain users' capabilities targeted at specific apps. The other thing they're trying to do is basically like a transaction record book. You know, kind of like your bank keeps track of all your transactions, and it has kind of like raw data associated with each one that sometimes you can understand and sometimes you can't. You know, like, what did I spend at whatever blah, blah, blah weird vendor? And then it turns out it's just like the shell company that's for something super benign. So that's like a bit like a transaction explorer. And most wallets are trying to provide that as well. And then the last thing they're trying to do is actually manage your private key and handle signing transactions. And that's really, I think, 3 different things. And in my mind, those should be 3 separate services. I think that, you know, applications should be building their own interfaces. They should really, you know, be in charge of the front-facing version of the application that you're dealing with. That's essentially what they're doing in the first place. And then there should be a separation between the transaction record keeping and the private key management. Because most wallets, you know, they're trying to provide a good user experience. Doesn't mean that they're going to be like security experts, but they're trying to wear all these hats at the same time. But if you think about what the transaction record keeping should be like, it should be this really sort of slick, you know, new banking thing where you have this like sense of an identity, and you're looking at your history of all the transactions you've had. You want to be able to sort of audit your own records. You want to be able to know, you know, what have I done there? However, most wallets today are doing this in a single key scenario where it's like, you know, what have you done with regard to a single key? Because they're keeping track of that key. But actually in the future, you're going to be wanting to manage many different keys for many different purposes. Some will be for different networks. Some will be for subkeys, which essentially gives you, you know, a different key per transaction type. So you're like, okay, I have a key that I share with my coworkers because it's just the like spend on office expenses. Or I have a key which, you know, I keep pretty loose because it's meant for voting on governance proposals. It's not going to be the same key that I have all my like large amounts of money held, or the key that's used for validating my validator. You know, obviously there's a lot of different things you can do on a blockchain, so you should maybe have a key for each of them. And then you need somebody to really like keep track. Where are those keys located, and what are the capabilities of each of those keys, and what are the transactions that each of those keys have been recording. But if you are going to be having all of these multiple things, you know, this is a single account user that has many different keys under it. And you want a unified idea of an account, but you want within that many of these keys and capabilities. So that's a really sort of great place to double down on that capability of wallets, while also increasing security capacity by giving up the control or storage of those keys and just keeping track of where are those keys stored. So here you've got an account on the Cosmos Hub that can do this one thing, and you've got that key stored inside of a Ledger device. Here you've got this other key that can do this other thing, and that key is stored inside of your wallet on your phone, or that key is stored inside of the Kepler browser inside of your browser, or maybe it's stored inside of the Looney wallet inside of your browser. Maybe it's stored inside of the Cosmos station. You know, there's all these different key solutions that should be, you know, focused on certain levels of security because you're using them for certain situations. Maybe you'd want to really beef up your security and do something interesting with Taurus, you know, that allows you to sort of swap them out or have these like accessible via Google Drive. That's like a situation that would be really exciting for things that especially are not so secure, but you want better user experience. Or maybe you want to use something like, what is that threshold signature that uses facial recognition as one of the key signing parameters. Anyways, separation of concerns here I think would be really interesting. And that's my full like galaxy brain pitch for the future of wallets. The midterm version of wallets is where they're all going to be sort of trying to do more than one thing at a time, just because that will be a better initial user experience. And for that, keep an eye out from Kepler Wallet, who will be providing that experience rather soon for various blockchains that are going out. Also keep an eye on All in Bits, who have been doing an amazing job on the Starport command line, which is for building blockchains quickly. They're doing a lot of work on trying to provide sort of a minimum viable wallet, so that when you do that, you also can sort of immediately ship with that. The other version of this Galaxy Brain thing that I really like is that wallet manager can be integrated directly into the app, so you don't need to download an extension to get your user to use it. They have like a wallet manager account, or if they don't, you know, they can sign up for one within the app based on like a pop-up or something like that. And then you don't bottleneck your whole user flow into forcing them to download something. However, if they do have key signing solutions in the future, they can tie it back. Anyways, that's 2 minutes over the 2-hour mark. I'm sick of hearing myself talk. You must be as well. Thank you so much for staying. If there's any other questions anybody else wants to ask, feel free to reach out to me, Twitter, wherever. Really appreciate your time, and have a great evening.
Thank you everyone for joining. We'll be sharing our resources in the Discord channel on the call with us. In the same time, we'll be publishing the recording very soon, and also we'll be sharing it on the Call with Us series on Cosmos.network. Make sure to follow the webpage where we'll be posting our future Call with Us sessions, and see you all next time.
Bye.